Okay, by 11. So we have to kick off and keep going with the arthropods. We looked in 28.1 at what an arthropod was, jointed appendages, all that. We looked at their body systems. Okay, body systems. Once I went over each body system, you need to know it, from nervous system to reproductive, excretory to respiratory, circulatory with the whole open circulatory system thing. Make sure you know that. Those body systems, very important, fair game. Okay? Now, we have to go into a little bit more of librarian mode here and discuss what the major camps of arthropods are. Arthropod is a huge, huge phylum. And in fact, there's a subphylum in Arthropoda, and it's a very tasty subphylum. Things like shrimp and crab and all that kind of fall into it. And we'll be looking at more or less sort of the major groupings. That tasty phylum, by the way, they're known as crustaceans. You might have heard this before. Mr. Crab from SpongeBob, well, he's a crustacean. Jacques from Finding Nemo, a little shrimp guy. I think he's a shrimp. Well, it doesn't matter if he's a crayfish. That's okay. He's still a crustacean. They're a pretty big group, and we'll talk about what the distinctions are amongst these different groups. Another major group, class Insecta, class Arachnida. So, without any more ado, we're going to get rolling. There's some major stuff on the course website that I want you to pay attention to. Looking through it here, some chapter package stuff, etc. These dissection videos, very good. Neat stuff from free material on Brain Pop's website, introducing the insects, spiders, checking out metamorphosis, right? And an overview of invertebrates in general. Really neat stuff, including some early arthropods here that'll really kind of blow your mind. Okay, so time to get into reflection mode. I love the software. It's very cool. In fact, getting you guys to do screencasts, I think, is more important even than me doing the screencasts. Let you play teacher for a while. Okay, so what have we got? Groups of arthropods. Well, we see butterfly, sort of like a butterfly here, and well, I can tell you right now that's class Insecta, but wait a minute, class, that's smaller than a phylum, isn't it? Yeah, and when you look at even insects as a class or arachnids as a class, there's even bigger groupings than that. Crustaceans themselves make a huge grouping. So here we go. 3 major arthropod groups. Well, if they're 3 major groups, let's label them. Number 1, crustaceans. Spiders and their relatives. Okay, so let's call this for what this is. Subphylum Crustacea. Subphylum? Yep, there are these little weird microdivisions. You'll see that we have subspecies. I've heard of infraspecies. You gotta have to kind of understand that the kingdom, phylum, class, order, family, genus, species thing, sometimes it needs a little help. We may not have enough categories for everything. So we've got subphylum Crustacea. It's a subphylum of Arthropoda, so it's just underneath it. Spiders and their relatives. Now, these are the arachnids. Come on, pen tool. There we go. I'm going to switch pens in a second if this keeps up. Class Arachnida, but I don't have the space for the A. And these guys here are class Insecta. Now, classes are pretty big. Of course, they're just one down from a phylum, but you get the idea. These are major groupings. Crustaceans, right? All of a sudden, I've got the SpongeBob theme ringing in my head here with Mr. Crab. But these guys, as far as crustaceans go, something you immediately have to understand about them is that their limbs always end with these 2 little points. When you look at fiddler crab, they've got this giant, huge claw, for example, they might have, but there's always one, two little branches. And in fact, when you go to eat lobster, look at all the little legs that go all the way down. You'll always find that they have all of their limbs end in these two little points. And we say that this group has two, or it's biramiate. Their limbs end in 2 points, as you see here. So, shrimp do that, lobster do that, crayfish do that, and even barnacles. Now, you might have forgotten what a barnacle is, so we got to pop out to the web. A barnacle, it looks like it has a little shrimp inside of it. A lot of people thought that a barnacle was more related to something like a limpet. So, you look at a barnacle and you think, oh, those things. Well, what the heck are they? They grow on whales, they grow on ships, they grow on anything. What's actually inside a barnacle? So if we say, hey, let's take a look at a cross-section of a barnacle, and we look at what's in there, like, wait a minute, what the heck is inside of a barnacle? Well, it looks like it's a little filter feeder. There's a little critter in there with biramiate limbs, and its little feet kind of kick up in the air. Here you go, like this. And it's using that to filter feed to bring down food into its mouth to feed itself. It's like, that's what's inside of a barnacle? It's just got a shell? Absolutely. It's almost like a little shrimp on its back. Very primitive little organism. It might look like that, but with its legs extended, you could see them like that. So there's more to a barnacle than you thought. Kind of like a little shrimpy on his back, sticking his legs up in the air to filter feed with. Who'da thunk it? They tend to have no neck. So unlike something like an insect, they don't have 3 body parts. They tend to have the abdomen down here. And then up here, they have the cephalothorax. And I can't color over that, so I'm picking a new color. There we go. About like that. And they have the cephalothorax region, which means that the head is fused with the thorax. Okay, now I make a major exception with your author of this book. They say first antenna, second antenna. That's nice. The first set of antennae are short, and they're known as, I'm going to zoom in on this so I can have space to write. On all my tests, I won't accept first antenna. These are known as antennules. It's ironic because the name's longer. And the second set of antennae are just known by the shorter name, which is kind of opposite to what they really are, like this. So what do we really have? Antennae are chemosensory organs. What does that mean? They can taste and smell the water around them with those antennae and those antennules. That's really what they do. Now that we're here, let's look at all the limbs. Hey, look, biramiate limbs. 1, 2, 1, 2, 1, 2. Each one of their limbs does this. Even as you go down here and you zoom in on this region down here, you'll see that their limbs, by the way, these are called their swimmerettes right here. Little tiny legs. They're not really for swimming. They actually hold their eggs in with them. And even those are biramiate. Okay, so the first 2 appendages, or limbs, if you will, are the antennae. But if you say first and second antenna, I'm not giving you credit. Antennules for the short ones, antennae for the long ones. Thank you. Thank you very much. The third set of appendages, the next thing that you would reach as you zoom in, as soon as we get past this and we get past this, you get into the bitey little rippy little mouth parts called the mandibles. So its mandibles more or less kind of come in, and they're like teeth and they shred whatever they're chewing on in between, and then they take it into their mouth behind. That's the idea. Biting, ripping, grinding. Incidentally, when you look at crustaceans, you say, how many legs do you have? Well, when you count them up, you say, all right, 1, 2, 3, 4, 5. These technically don't count as legs. Well, 5 pairs adds up to 10. Oh, it's a decapod. 10 feeties. Okay, no problem. But the first pair of feet are kind of interesting. They're called chelicerates or kilipeds. I've kind of heard it that way. And these guys do have handedness. In fact, you'll find one tends to be a little bit bigger than the other. My recommendation, important recommendation to you guys, is if you're going to cook these guys, keep the elastic band over their kilipeds so that they can't get your finger in there, because they can close with tremendous force. But they're kind of like an alligator, right, where they can't open their mouth very easily. So these are, used for grabbing and manipulating and crushing and cutting things. Good luck getting their claw off your finger if they decide they want to clamp down. Okay? The swimmerets, they talk about them for swimming, but when you look at the function, especially in the females, they sort of form this neat little brooding chamber, right? Let's focus in on what they do. So if the female, it's interesting how the female, she'll actually receive the male sperm, hang onto it for a while, and then release it onto her own eggs. They do external fertilization. It's really, really unique. She has like a receptacle chamber where she just takes the sperm for a while. But the little swimmerets can be used as a brooding chamber to kind of, and I'm drawing it poorly, but to hold on to the eggs and to kind of keep them safe up underneath her abdomen. And there's a way to tell male and female crayfish. That's what we use in the lab. But if you go out and check with lobsters, you have to look for basically the seminal receptacle. And it's basically it's just down, oh, of course I don't have the tool. It's basically just, give me my pen tool. You'll find it just underneath, kind of in this area here, approximately. The tail itself is kind of made up of 3 parts. Here it's just being generalized, but when we get into lab, we'll talk about the Arachnid and the telson. It's a propulsion device. I mean, no surprises there. It's paddle-like, and it's special extension off the abdominal region. Does exactly what a tail should. Now, since we're going to sneak out, this is very sneaky. We've cruised out of the crustaceans. Now let's talk about class Arachnida. They're named after, if you know about the Greek legend, and I guess I'll tell this story as soon as I finish my A there, about Arachnia. I think I'm saying her name correctly. I used to love this legend. Arachnia. Let's see if I can find it. In Greek legend, there was let's see if I can find it. Closest thing, I guess, I'll just use a spider web as my background here, like this. There was in Greek mythology, you never compared yourselves to the gods. If you did, you were likely to incur the wrath of the gods. And there was a mortal woman, a Greek woman, who could do the most amazing work on the loom and weave like nobody else could. And to make a long story short, she boasted about her skill and said that she could probably best even the goddess of wisdom, the Greek goddess Athena. Well, as soon as you do that, it's on. And a contest was held to see who could produce a better product, Athena or Arachnia. So after the judgment was rendered, Athena won, but instead of feeling vengeful, she was extremely impressed with her competitor, Arania. Her competitor, in true form, thought that, uh-oh, I insulted a god, and now the god will wreak vengeance upon me. And Arania killed herself, and it was done by hanging. And that the goddess Athena, when she finally found Arania and wanted to congratulate her for her amazing work, discovered that she'd killed herself, touched her, and her body shriveled up, and she said, no, you won't die, you'll continue to weave forevermore, you make such amazing work. And then Arania became the first spider. So there you go. Interesting stuff. That's kind of the legend. So when you look at why they're called arachnids, it's kind of in reference to Arania and sort of her amazing abilities and her, of course, tragic story. But what in science really makes a spider an arachnid? Well, we'll zoom right in on it. They have got a horrible bitey mouth part, right? Now this bitey mouth part is known as their chelicera, or chelicerae, their fang. So I've drawn it in, of course, sort of vampire-like on this. Now, it's not just spiders that have this. Look at the size of this tick. Whoa, big one. And you got to watch out when they bite you. Ticks in particular can have awful little bacteria in them. And that, ticks, for example, can cause, you can get Lyme disease. And it's not from the tick, it's from the bacteria that they contain. It's kind of like if you've ever remember hearing about the bubonic plague. People thought that they were getting the bubonic plague from the rats, but they were actually getting it from, I think it was a little bacterium known as Yersinia pestis was causing the disease. Now, something like Lyme disease is highly treatable, but you have to get antibiotics to deal with it. So we've got spiders and we've got ticks, we've got scorpions, right? Interesting thing is there's no antenna. So if you find something, you're like, hey, it hasn't got any antenna, and it's got a big old bitey mouth part, odds are you're looking at a spider or its relative. So in this right here, you can see the chelicera, and up here there might be a venom sac. A lot of chelicera are hollow, so as to deliver a nice little payload of venom to deal with you. And some of that venom can act on your blood. Some of that venom acts on your nervous system. They have all sorts of ways to go about poisoning you, these little devils. Count the legs. That's the next important thing to do. Right? 1, 2, 3, and 4. So 4 pairs, 8 legs. Okay? Talking about the chelicerae, they've already kind of mentioned this. Good idea to incapacitate your prey before you eat them, right? A little less work, a lot less likely to damage you. Simple. They've got pedipalps. Some people confuse the chelicerae. The chelicerae are obviously here. Okay, so this thing. The pedipalp, palp means to grasp. Okay, so the pedipalp is really just sort of a grasping leg, and it'll be right near the face, and it helps them to bring their prey in. Oops. A couple of neat little classes. You should pay attention to this since we're looking at Chelicerates. Chelicerates are kind of a broader way of classifying arachnids. Okay. So Chelicerates really come down to 2 classes. There's some really old ones. So when I started this lecture, I mentioned arachnids. Okay, because that's really what's left of, let's define this for what it is. Uh-oh, you didn't say this at first, but I am now. It's subphylum Chelicerata. Okay, so the cat's out of the bag, right? Wait a minute, we had another subphylum. Oh yeah, Crustacea. Well, you got to remember, there's a lot of these critters. So we're messing around a little bit by introducing a subphylum. And by we, I mean the scientific community. Horseshoe crabs are kind of like nature's leftover trilobites. So they're off kind of in their own group, their own specific class. But the arachnids, as soon as I talk about anything with fangs, I go off and start ranting and raving about arachnids because our spiders and mites, ticks and scorpions, and that's pretty well what you're talking about with something that's a chelicerate these days. Horseshoe crabs, meristomata, they're super old. I say don't mess around with them because they are chelicerates. They do have a basically a little fang-like thing that you really don't want to contend with. Okay, pretty old, 500 million years. I don't know, half a billion years, and they haven't changed much. Reason for that, they're doing a pretty darn good job of just being the good little detrivores they always have been, eating whatever they find on the beach. Spiders, if you want to see spiders, go down to temperate rainforests, go down to Australia, and you'll see all the spiders you can handle because they can go after small birds, small animals, mice. They can take them down, and that's a great meal for something, an arachnid like a spider. Spiders producing silk. I have to zoom in on that. There's the silk glands over there. And silk is a very interesting protein. We talk a little bit more about this in Biology 12. But silk rope is incredibly strong. In fact, silk rope is better than, because of its flexibility, it's even better than tensile steel, like cabled steel. Silk just isn't much good when it gets wet. I'll say that. But it is, if you were tied up with silk rope, there's no way, you just would not get out. Shy of cutting it, it's extremely strong, especially when you stretch it lengthwise, and it's elastic, and it just won't let go. So what's it used for? Well, they do the webs, capture prey, protect their eggs with it, right? Wrapping up poor Frodo Baggins to be a meal for later. If you haven't seen Lord of the Rings, well, that Frodo comment is not leaving. You'll have to just go watch Lord of the Rings to understand that. The silk it's kind of like a protein. What happens is it gets ejected out of the spinnerets, and at that point, as it's exposed, comes from these glands here, right? And as it comes out and hits the air, it actually takes on its form. So little spinnerets, and they do exactly what they say. It's that way the name actually makes sense. Mites and ticks. A lot of the males are smaller. They're parasitic. Mites and ticks, you can think of them, a lot of the ticks come to mind as sort of vampires, little bloodsuckers that they are. The problem with ticks is they're so small and they're biting on you. And if a tick, how Lyme disease works, if you look at Lyme disease, let's pop out. Lyme disease symptoms, there we go. If you get bit by a tick, it's not the tick that's the problem, it's the bacteria. And here's a little tick just slurping on somebody. And it's infected you with a bacterium that causes this bullseye-shaped rash. This is very characteristic of Lyme disease. And it's treatable, but what you have to do is you have to get treated right away. So where would you get Lyme disease? I don't know, your pet brought in a tick that was infected. You're out in the forest, you get bit by a tick. The tick, it's not the tick's fault. The tick consumed blood of an infected animal, and you just got bit by the tick, and you're just part of a vicious cycle. That's what Lyme disease is. And ticks will burrow into your hair, and they'll burrow into your skin, and into your crivets, and all sorts of places. Right? They have to be removed before they start administering the antibiotics. So if you get Lyme disease, you'll feel muscle aches, chills, headache, general fever, and then there's that characteristic rash. So first of all, you got to find the tick and remove it, and then start treating the person with antibiotics. That's not the hard part. Okay, moving on. That's gross even for me. Scorpions, they have that nice watertight body, and they've got 8 legs. Now these guys, their pedipalps are kind of, they're like claws. They're almost like kilopeds. But scorpions, interesting, will actually chew on their prey before they bring them in. Just sort of tear them apart and chew them. You don't have to die from a scorpion sting. It's just you really don't want to get stung by a scorpion in the first place. I remember watching Fear Factor, and the first thing you do is you take this thing off, and then that's it. They have no ability to sting you. Okay? Their stinging Chelicerates is gone. Too bad, it's history. Right? We should point out that unlike lobsters, crabs, they're not biramiate. Their legs just come down to a single point. Okay? Peg legs. And you don't see a lot of... that's kind of the distinction, I guess I should say, between the crustaceans and everything else. Everything else seems to not be biramiate. Okay, that's not their thing. And arachnids don't have... I mean, they've got 4 pairs of legs, generally 8 legs. There are exceptions. And they've got the little chelicera fang. Insects, like arachnids, are uniramiate, like this. Okay, so let's write that in. Uniramiate. Okay. But insects, like centipedes, millipedes, etc., they can have antennae. That's not a problem, right? They'll generally kind of just have 1 pair of antennae. So we should point out the difference between, okay, this is a millipede. Kind of looks like a long tube with lots of legs. It's not that it has 1,000 legs, it just has lots and lots of legs. Like a worm with legs. There you go, millipede. This little guy tends to be kind of a vegetarian. He's not so brutal, right? Now, this is not a millipede. Okay, at this point, I need to point out a centipede. There we go. Now, centi does mean 100. They've got lots of legs. But centipedes are very voracious hunters, well-developed head region. There we go. Okay, if you see these bigger segments, you're looking at a centipede. And yes, we do find these around Prince George. Nice little creepy crawly, hey? Okay, there you go. So now you know the distinction. So they'll have a pair of antennae. Now the antennae do not branch. And really, as far as insects go, you've got to remember, okay, we're looking at class Insecta. Uniramiate, 1 pair of antennae, and they have 6 legs, which equals 3 pairs. And you have to be aware of that, okay? If it came down to just counting the legs, if you see 6 legs, wham, it's an insect. If you see 8 legs, wham, it's an arachnid. If you see 10 legs, it's a decapod, but we won't go into that. If we were looking at a decapod, then I'd want to look at its legs and see, hey, is that a crustacean? Is it biramiate? Okay, that takes us to the end of section 28.2. Class Insecta. Try not to make you dizzy here. Okay. Subphylum Chelicerata. Obviously the arachnids, things like that. And, going back up to the top, quick. Ah, there we go. Our friends with 10 legs and biramiate limbs, our crustaceans, which I think I'm going to have tonight with steak. Okay, ladies and gentlemen, that's it. It's 3:34. It's quitting time. And it's Friday, and I hope you have a good day. Ciao.